Hi, folks. Thanks for joining me today. My name's Ronnie Garrity, and I work on the Azure SDKs for C++. And today, I'll be going through how you can set up a C++ project using CMake and vcpkg that uses our Key Vault and Identity libraries. Let's get started. Here you can see I've got open the Azure SDK for C++ repo. This is where all the source code for our various C++ Azure libraries is located if you'd like to take a look. If you'd like to follow along with this sample, there's a written up guide as well in the samples integration CMake vcpkg folder that you can follow along, and it even has sample files if you want to copy and paste. For this tutorial, you'll need to have CMake installed. You can grab CMake from the CMake download page where you can install the installer for your operating system, or if you feel like it, you can grab the source for CMake and build it yourself. Like I said, we'll be using CMake along with vcpkg today. If you're unfamiliar with what vcpkg is, it's a C and C++ package manager solution that we'll be using to grab the two libraries from the Azure SDK for C++ and integrate into our project. If you'd like to search the available packages on vcpkg, you can click the Packages tab at the top and then search for your packages. If you type in Azure, you'll start to see all the different libraries that are available in the Azure SDK for C++. Today, we'll be using the Security Key Vault library for secrets, which is right here. We'll also be using the Azure Identity library for authentication, which you can get to right here. So now we'll get started on our steps. Like I said before, we'll need to have CMake installed. And if you just type in your terminal CMake -- version, you should see an output telling you what version of CMake you have installed. The next step will be to install vcpkg. You install vcpkg by cloning the vcpkg repo onto your machine. You can clone the vcpkg repo with this command, git clone, and then the URL to the vcpkg GitHub repository. Hit enter. It'll take a couple seconds to download the repository. The vcpkg repository is now done being cloned to our machine. So we'll cd into that vcpkg directory that was created. And if we take a look, you should see a couple files. The main one we're looking for next is the bootstrap-vcpkg.bat. There's a matching bootstrap.vcpkg.sh. If you're on Mac or Linux, you'll want to run that script. But today we're on Windows, so we will run the bootstrap-vcpkg.bat file. Okay. Now that that's done, we have a nice little message here about vcpkg being installed and the version we installed specifically. Don't worry if your version doesn't match up to this. I'm sure by the time you're going through these steps, a new version of vcpkg has already been released. If you already have vcpkg and are interested in updating your version of vcpkg, all you need to do is go back to that repository on your machine and simply do a git pull to pull the latest version from the repository. You'll want to remove the installed directory that'll show inside that repository on your machine, and then you'll want to rerun that bootstrap file. Now that you've installed vcpkg, we'll want to set up a vcpkg root environment variable on our machine. On Windows, we'll just enter this command, but on Linux or Mac OS, you could export the vcpkg root environment variable. You want to make sure you're setting that to the location where you installed vcpkg. So we'll hit enter. Next, we'll want to add the vcpkg root environment variable to our path, which we can do with this command on PowerShell. Again, in Linux or Mac OS, you'll just want to export, changing your path command to add the vcpkg root environment variable to the end. Now, we should be able to call vcpkg from anywhere, and we can test this by typing in vcpkg -- version. And you can see it's printing out the version of vcpkg we had. This is going to match exactly what we saw above when we installed. Again, yours might be different depending on when you installed vcpkg or when you last updated. Now that we have vcpkg and CMake both installed, we'll start setting up our project. So I'm going to go back to my home directory, and I'll create a directory for this project. I'll move into that sample project directory, and I'll start creating my files. The first thing I need to do in my project directory is create my C++ file. So I'll simply echo into a C++ file. And now if I take a look, I've got my main.cpp file. After that, I'll want to create my CMake list text file. I'll do something similar. CMake lists plural .text. Create that. And you can see that's in my project directory as well. The last thing I want to do is inside my project directory, I'll want to make a build directory. So I'll just type make dir build. All right, clear. And at the end of all that, you should have two files, CMake list.txt and main.cpp, and one build subdirectory. Now that we've created our files and our build directory, I've opened up this sample project in VS Code. It doesn't really matter what editor you use for this tutorial. We won't be using any editor-specific features. We'll be running all of our commands through the terminal. So now that I'm in the editor, I'll open up my CMake list.txt file, and I will remove the little CMake text that was in there, and I'll replace it with the starter text for our CMake file. So first thing we're doing is stating the minimum required version of CMake needed to run our CMake.txt file or our CMake build process. I am then setting up our CMake project, calling out our Azure sample, stating a version and stating the languages. And then I'm finally adding our executable to the project. It is our main.cpp file. This is our basic CMake lists file. Now we're ready to start setting up our C++ file. So I'll open up main.cpp. I'm going to start off just by throwing a simple hello world program in there, just to make sure we're building everything all right. Now that my hello world code is in there, I'll open up a terminal with inside Visual Studio Code this time. And it's still just a simple PowerShell terminal just in my sample project directory. I'll now run our CMake configure command, which is CMake -b, and then into our build subdirectory. CMake is going to go through finding our C++ compiler, which on Windows, it's going to pick up the MSVC compiler from Visual Studio, which I also have installed. You're free to use any other compiler you'd like, but for Windows, I find it easier to just use MSVC. All right, so it ran our configure, and if we expanded our build folder now, you'll see it's now populated with a few a few CMake files. All right, now that our build process has been configured, we'll want to actually run our build. So to run our build, we'll do CMake --build, and again, point to our build directory. All right, and that is our build. We check our build again. We have a few more files. By default, CMake is building in debug mode. So it put our executable file under a debug subdirectory. So if we want to run that, we can go to build, debug, and then our Azure sample executable. And when we run that, we can see that we got our hello world message. Great. So we have a very simple CMake C++ project started. Now let's get started in adding in vcpkg. I'll clear away what's already in our terminal, and I'll clean up our folder structure on the side there a bit. The first thing we want to do to integrate vcpkg into our project is by creating a new vcpkg application. You can do so by typing vcpkg new -- application. Okay, enter. This will create two files in our project directory. We have a vcpackage.json file, which is currently an empty JSON file, and we have a vcpackage-configuration JSON file. This configuration file has a few pieces of information about our baseline for vcpkg. vcpkg is built on Git, and it uses a Git repository as its package repository. Here in the VC package configuration JSON file, we have a few settings related to how we want to consume packages. Most importantly, we have our VC package baseline. The baseline is a commit SHA from the VC package GitHub repository. It basically states we want to consume packages from this commit in the VC package repository's history. We can close these for now and go back to our terminal. Using VC package in this manner is what's known as manifest mode. In manifest mode, we get the vcpackage.json file, which allows us to commit our VC package dependencies directly to source control. So when other contributors want to work on our project, they can also clone down that vcpackage.json file and just install the packages that are needed for this project. We'll now add our two Azure SDK libraries to this project. And you can do that with the vcpackage add port command. And we're specifying we want to add the Azure-identity-C++ library and the Azure-security-key-vault-secrets-cpp library. We'll hit enter on that, and it'll be pretty quick. You'll notice after we enter that command, our vcpackage.json file has changed. We now have two dependencies listed in this file, which are both the ones we entered in the command. Next, we'll need to make some updates to our CMake list.txt file. So let's hop on back over there. So now let's integrate CMake with vcpackage. Back to our CMake list.txt file, we'll want to add a line directly under where we're stating the minimum required version of CMake, where we're setting the CMake toolchain file property to the location of the vcpackage CMake module. You'll want to replace this part of the path with the path where you installed VC package. So on my machine, that was c/users security VC package. And if you go and look where you installed VC package, you will see a script subdirectory, a build system subdirectory with a file called vcpackage.cmake. It's very important that you add this line before you have your project statement line. The CMake toolchain part of our build needs to run before we start setting up our project. Next, we'll add the two lines to find the new packages we just installed. So you can do that with find package and then Azure-identity-cpp and find package Azure-security-key-vault-secrets-cpp. You'll notice that these are the exact library names we used when we ran the vcpackage add port command. These should be exactly identical. Okay. After that, we'll want to jump down below where we're adding our executable in our CMake and set up our target link libraries, which you can do with this line. So we'll do target_link_libraries. We'll reference the project we set up earlier, and then we'll reference the libraries we're wanting to link. Note that these are different names than we used in the find package and the add port commands. We're going to state the namespace the libraries are a part of, and then : Azure-identity for the identity library, and then Azure-security-key-vault-secrets. They are very similar names, just remove the -cpp command. We'll save that. Now that our CMake list.txt file is all set up to be properly integrated with VC package and pull in the two Azure libraries we installed, let's talk about how we'll be authenticating to Azure in our program. In our program, we'll authenticate using what's known as a Azure CLI credential. And to do that, we need the Azure CLI. You can download the Azure CLI using the instructions here. There are instructions for Windows, Mac OS, and these following Linux distros. Once you have the Azure CLI installed, you should be able to run Azure or AZ --version and get an output stating the version of the Azure CLI you have. Now to log in with the Azure CLI, you just need to type in AZ login. Hit enter and a pop-up window should show for you to pick your Microsoft account. And then you should get a option in the terminal to select the subscription you'd like to log in through. I have already logged in, so we are ready to go. Once you're logged in with the Azure CLI, you can use the Azure CLI to create your Key Vault instance for this project. You can do that with the following command, AZ Key Vault create -- resource group. You'll want to replace this section with the name of your Azure resource group, then -- name, and then replace this section with the name of your Key Vault instance. You can also follow along to this tutorial if you've created your Key Vault instance via the Azure portal. All we need to proceed is our Key Vault URL. So if you're on the portal, you want to grab that from your Key Vault page. If you did it using the Azure CLI, you should have seen in the output a property called Key Vault URL. We'll now create an environment variable to store our Key Vault URL. On PowerShell, you'll use nv:\Azure_Key Vault URL. It's important that you keep the environment variable name as is shown here if you don't want to have to change any of the C++ source we'll be using. And then set that equal to your Key Vault URL. Most likely you'll have to replace this section with the Key Vault name you chose when creating your Key Vault resource. So once you've entered in your Key Vault URL environment variable, we can now move on to updating our C++ code. So let's shrink our terminal and go back to our C++ hello world. We'll remove the current text in the C++ file and replace it with the following. Now that we've got our new C++ code in our C++ file, you might notice if you're using VS Code along with me that we're getting an error on our include statements here. I'll show you how to resolve these in VS Code in a bit, but I'd like to first continue with going through our C++ sample here. So we have our includes for our identity library and our Key Vault secrets library, as well as IOStream. We are using the Key Vault secrets namespace, and then we get into our main function. First, we have a little bit of output text just saying our program is starting. Then we get into our try statement, which most of our Azure code is going to be in, so that we can catch any Azure exceptions. The first thing we do here is get our Key Vault URL from our environment variable. If you remember, I said it was very important that you set your environment variable to Azure_Key Vault_URL. If you did not set the environment variable to this text exactly, you'll want to change the string in the C++ code. Next, we'll create our credential or Azure credential using the identity library. So we create a variable called credential as a shared pointer. And we're using, like I said, the Azure CLI credential. What the identity library will do is it'll pick up on our Azure CLI login that we did previously. Next, we create our Key Vault secret client that we pass in our URL and credential to, and then we can start playing around with Key Vault. First, I'm creating two strings. One is going to be the name of our secret. I'm calling it my sample secret, and the value for our secret. Do not tell anybody this is the secret, but the text is my super secret value. Okay. Then we'll use our secret client to set the secret, giving it the name and the value. We can then get back that secret, again, using our secret client here. We'll use the getSecret method, passing in that secret name and getting the value, which will return our Key Vault secret type. Then to get the value out of that secret we just got, we'll use that secret variable, its value property, make sure that it has a value, and if so, get that value property, and if it does not have a value, add a none returned. Then finally, we'll put some output text that says our secret was returned with whatever the name we got back was and its value. Then, like I said, we're catching any request exceptions that may occur. And then finally, we're putting some output text to say the program has ended. Ideally, if you followed the steps along perfectly, we will not get any exceptions. Now that we have our Azure sample C++ code in our project, we're ready to reconfigure our CMake build. So if you remember before, we made changes to our CMake list.txt file. And when we configured our CMake project, a bunch of files populated in our build directory. Now that we've made some changes to our CMake list.txt file, we'll just want to reset our build. So we'll do that with the following command on PowerShell to remove the build directory and all of its contents. So remove item -path, path to our build directory, recursive force. You can now see our build directory is gone, but don't worry, we'll bring them right back. So now we have a fresh new empty build directory, and we're ready to reconfigure our CMake build. If you remember the command we used before to do this, it's CMake-build, and then the path to our build directory. We'll hit enter. And you'll notice something new about this time running the config. We can now see right here on the second line, before it jumps down, we now see the running vcpkg install command. This is a little clue to let you know that CMake has picked up on our vcpkg CMake module that we added to the CMake toolchain, and it is now running through looking at the packages we have listed as dependencies in our vcpkg.json and grabbing them and installing them. It's also grabbing all the dependencies those dependencies have. So one nice thing about vcpkg is it not only manages your dependencies, but the dependencies of your dependencies. So it'll grab the 2 Azure libraries we want for this project and all their dependencies. It'll also build out all those dependencies. It's grabbing the source, and it'll then build them for our environment. Running the CMake configure command with vcpkg for the first time may take a few moments just so that it can build all of the libraries it's installing. On subsequent runs of the CMake config command, it'll be much faster since it has already built those libraries and has cached away the builds. All right, now our config has finished, and you can see in our output 2 things I want to point out. It is now talking about the libraries we have listed in our dependency file, in our vcpkg.json file. It's telling us to add some lines to our CMake lists. But if you notice, we already added these lines into our CMake list.txt, so we're good. Now that we've reconfigured our CMake project, we can run our build. And if you remember the build command, it is CMake --build, and then point it to our build directory. Okay, it put that build in the same place it did last time. So we'll go into the build directory, into debug, and rerun our Azure _sample executable file. And there's our starting program output. And there's the rest of our output. So we can see here, it's telling us the secret returned with the name of my sample secret, and its value was my super secret value. And then we ended the program. Again, don't share this with anybody else. So now that we've reconfigured our CMake project, built our program, and run it, I'll get back to something I mentioned earlier, which is in VS Code, how do you have VS Code recognize your include statements? And all we have to do is hover over one of the error lines. We'll hover over the include for the Azure identity line, go to the quick fix, and it'll already suggest to add the build _ vcpkg installed directory to our include path within VS Code. We can click that. It'll bring us to our C++ settings for VS Code tab here. And if we scroll down, we can see in the include path section, we now have an additional entry for this location. And if you actually look Under our workspace folder, that's just our project directory. In our build directory, there is a vcpackage_installed directory. If we go in there, we can look at x64 Windows. That's our specific triplet building for 64-bit Windows machines. And we have a include directory. And here you can see is where where vcpackage will store all of our include files. So we go to Azure, and we've got our identity library headers, and we have our key vault secret headers here as well. Okay. But now that we've added those to our include path in VS Code, we are no longer getting any error messages saying it cannot find the files. And that'll also enable us to get our full form of IntelliSense, picking up on our types and giving us method signatures with nice pop-ups, if you're interested in working in VS Code. So now we've gone through how you can set up a vcpackage and CMake C++ project and pull down 2 libraries from the Azure SDK for C++. The last thing I'd like to talk about is how you set this project up to work with collaborators. How do you work together? In our sample project, there are only a couple things we don't want being sent up to a GitHub repo for collaborators. We want to hide our build directory because we don't want to be pushing up all these different build files that are here that are very specific to our development environment. And we'll want to make sure that folks know to change this CMake toolchain file path to the location where they installed vcpackage. This is unique to our machine. So to deal with the build directory, we'll add a file to our project called .gitignore, and we'll type build. This will stop the build directory from being pushed up when we push this project up as a Git repository. Finally, again, just make sure you're letting folks know who you're collaborating with that to first configure their CMake project, they'll need to update this file path. So now that we've set up our project to work with collaborators and we push it up to a GitHub repository, I'm going to show how a collaborator coming in can work with our project. And I'll do so on WSL running Ubuntu, so you can kind of see from a different dev environment perspective. So here in my terminal, I'm currently in my home directory. I'll clone the repo that I put up. So now I've cloned down the repository I pushed up, and if I cd into it, you can see we have all of our same files here. So, like before, we'll need to update our CMake list.txt file. So I'm now going to open this up in VS Code to do so. So now I've opened the project in VS Code again, this time from WSL. I have the WSL extension running for VS Code, which allows you to run VS Code within your WSL environment. Like we mentioned before, the first thing I'll need to do is make sure I update this CMake toolchain file to the directory where I've installed vcpackage on this machine on WSL, which reminds me, I haven't yet. So I'll do that in the exact same way I did before. So now I'll install vcpackage just like I did before, just using the Linux commands this time. So why don't we go back to my home directory and I'll put vcpackage there. I'll run the git clone command for vcpackage. It'll again clone the repository down. Great, now I can cd into the vcpackage directory. And if we take a look here, we've got similar files. Again, we're going to run our bootstrap script, except this time I'm going to run the bootstrap-vcpackage.sh file and not the bat file. You can see that when I tried to run the bootstrap.vcpackage.sh file, I got a couple errors. To run this script, On Linux, you do need a couple of dependencies, and it'll tell you need curl, zip, unzip, and tar, and it'll give you the command for various different Linux distros to install. So I need to grab the Ubuntu command, which I entered. I'll enter my password now. It'll grab those tools for me. Perfect. And I will try running again. Great. We have a similar output to what we saw when we installed on Windows. The VC Package Manager has been installed, and here's the specific version we have. Again, it does not matter if you have a different version. I probably expect you to, as new versions of VC Package come out all the time. All right, now that we have VC Package installed, we can add the VC Package directory to our path. This isn't necessarily needed to start where we're starting, since the project has already been created, and our previous developer selves have already run the VC Package create new application command and the add port command, but nonetheless, it's good practice to do. So here's my path to VC Package. I'll add this to my path. Great, so now when I run VC package -- version, I get the version of VC package I have installed. All right. Now that I've properly installed VC package, I'll want to update the CMake list.txt file so that it contains my route to VC package. So we'll replace this section with /moneyg/VC package. Just like that. And we'll save that. So now it's properly pointing to where the VC package CMake module is on our machine. So now that we've edited the CMake list.txt file to properly point where we've installed the VC package CMake module, we can start and set up our build and configure our build. So now that we've properly configured our CMake list.txt file to point to where we have installed the VC package.cmake module, we're ready to set up our build. So we'll traverse back to our project directory, which I have done. Let's see, we've got all of our project files here. I'll now create our build directory again with make.build. You can see there it is, nice and empty. And now we can run our CMake config command again. So I'll run CMake-b and then point to our build directory. And we've gotten an error. This can be a very common pitfall that people run into. In our CMake list.txt file, we're currently stating that the minimum required version is 3.30.0, but on my machine, when I type in CMake -- version, you can see I only have CMake 3.22.1. You'll want to make sure that if your CMake list.txt file uses any CMake features in a version, specific version, that you are at least using that version. I know for our specific instance that we're not using anything that is not also included in CMake 3.22.0. So I'll edit the CMake to just show that as the now minimum required version. And when I rerun our build command, we should be off to the races. And you can see again, just like before when we ran CMake or CMake config command for the first time, we're seeing that running VC package install command. So again, it is going, grabbing all of our dependencies, and building them now for Linux. And again, this could take time for the first config. On subsequent configs, it'll be much faster. Okay, you can see on our config we got an error when trying to get some of our VC package dependencies. If I scroll to the top here, I can see that we're getting an error from CMake from VC package saying it cannot find package. And it even gives us the command we need to grab it. So why don't we grab that and try our config again. So now our config has completed, and just like before, you can see it's showing us that text to add to our CMake file for finding the package and adding it to our target link libraries for both our identity library and our key vault secret library. Since we cloned the repo and our first developer selves have already done that for us, we don't need to do that. Now that it's configured, we're ready to build. So we'll run our CMake build command, CMake -- build. Again, point to our build directory. All right, and that's our project built. We'll now run. Again, our build is getting put in our build directory, and on Linux, it's not being thrown into a sub debug directory. It's just here at Azure Sample. So if I go cd build and show what's in the build, you can see there's our Azure Sample executable. So we'll run that. On running our Azure Sample, we got another error, and it's because we're forgetting one more thing. We are no longer authenticated using the Azure CLI. We need to re-log in with the Azure CLI. So again, if you need to install the Azure CLI on Ubuntu. To check if you have it, you can do az-version. Get your output showing what version of the Azure CLI you have, and then do az login. So after using the az login command to log in on WSL, it'll then paste out a link that you can go to. It won't give you a pop-up since there's no graphic interface for WSL. But you go to that link and it'll let you authenticate, and then back in the terminal, you can pick the subscription to use. All right, now that we're logged in, I'm reminded of another thing that we have to set up is our key vault URL environment variable. So on Linux, you can do that pretty quick. Again, just setting another environment variable. We'll export our Azure Key Vault URL. Again, it's very important that you follow this text exactly, and you'll want to replace this part with the name for your Key Vault instance. So now we have our Key Vault URL environment variable set up. We're logged in through Azure. Let's try running our program again. So again, in our build directory already, you can see we have our Azure sample file. So let's run it. And there's our output. We're starting our program. Our secret name with my sample secret is retrieved, and it has a value of my super secret value. And then we end our program. So now we're ready to start making any other changes we need to make to our C++ file, enhance it, write our own custom logic, and be able to test and build that and commit it back to source control. If you'd like to get in contact with anyone from the Azure SDK for C++ team, feel free to take a look at our GitHub repo and peruse our source code and leave an issue on the repo. We'll reply promptly. You can also reach out to us on Twitter at Azure SDK, as well as our Stack Overflow on stackoverflow.com/collective/Azure. Again, thank you for joining me today, and I hope you have a great day.